So lately, students have been asking me, what is the difference between electron geometry and molecular geometry? So very briefly, let's discuss VSEPR. So VSEPR stands for valence shell electron pair repulsion theory. Remember, we're talking about electrons here, y'all. So again, electrons, if you put two pairs of electrons together, they're going to repel. Why? Because both of them are negative. So again, electron pairs are around a central atom. They're going to repel each other and they're going to try to arrange themselves as far apart as possible, okay? So when you have two geometries and you have electron geometry and molecular geometry, this is the difference. This is the key method for you to remember this. Electron geometry considers everything. It considers lone pairs, single, double, and triple bonds are all treated as an electron domain. And some of you are going to be like, what is an electron domain? I'm glad you asked. So this is one group. This is another group. Again, 1, 2. So again, the way that I look at it as group. So I have two groups. So I have my steric number is 2. Again, this could be a lone pair, or this could be a double bond, or it could be a triple bond. Again, it's still going to be considered one group. Okay? Now, 2 is linear. Again, we're talking about electron geometry. 3 is trigonal planar. 4 is tetrahedral. 5 is trigonal bipyramidal. And 6 is octahedral. And I have the degrees for you guys in case you need to know it. Now, here's my trick for at least the first 2 degrees that you need to know. Think about this is a circle. So if I divide it in 2, that's 180 each side. If I divide it in 3, I have 120 in each piece. Okay? So that's my trick for remembering those degrees. So again, 2 is linear, 3 is trigonal planar, 4 is tetrahedral, 5 is trigonal bipyramidal, and 6 is octahedral. So again, electron geometry takes into account what? Lone pair, single, double, and triple bonds. They're all treated as an electron domain. Now that you have this memorized, let's talk molecular geometry. So this is something I need you to understand. When there aren't any lone pairs, no lone pairs, the molecular geometry is the electron geometry. They're the same. The molecular geometry is the same as the electron geometry when there aren't any lone pairs. Now, when you have lone pairs, they're not the same. So that's why students get confused and they're like, wait, but I thought they were the same. They are the same when you're talking about only having bonded electrons. They're the same when there aren't any lone pairs. As soon as you put a lone pair, that molecular geometry is going to do what? It's going to ignore the lone pair. So your molecular geometry is going to be different, okay? So again, your molecular geometry is the same as the electron when there aren't any lone pairs. When you have lone pairs, they're going to be different, okay? So for example, this you have a single bond and a single bond. They're both bonded. You have 2. So again, it's going to be linear in the electron geometry and it's going to be linear in the molecular geometry. Okay, let's go trigonal planar. Again, all of these are bonded. So 1 bond, 1 bond, 1 bond. You have 3. It's going to be trigonal planar in the electron and trigonal planar in the molecular. Now, I have a lone pair now. Is it the same? No. The name now is going to be bent. It's only considering 1 and 2. I mean, yes, this exists as the steric number is going to be 3. But again, it's going to ignore that lone pair. So the geometry is going to be bent. Okay? Now let's keep going. When you have 4, again, these are all bonded. 1, 2, 3, 4. So it's tetrahedral in both the electron geometry and the molecular. Now, what if you have lone pairs? So if you have one lone pair, it's going to be trigonal pyramidal, okay? If you have 2 lone pairs, it's going to be bent. and water is usually 104.5, just for you to know. Okay? Now let's go to the next one. Let's say you have 5. Again, if they're all bonded, so it's going to be trigonal bipyramidal in both the electron and the molecular. But let's say you start putting lone pairs. Now the molecular geometry is different. So if you have 4 bonded and 1 unbonded, or 4 bonded and 1 lone pair, that's seesaw in the molecular. If you have 3 bonded and 2 lone pairs, that's T-shaped. And look, y'all, it looks like a T. Okay, that's where the name came from. And the seesaw here, think about it. You're on a seesaw. That's what it looks like. So that's pretty self-explanatory, okay? Now, linear makes sense. You have 1 line and 3. Again, you're ignoring these. If these didn't exist, you would just see 1 line. That's why it's called linear. Again, you're ignoring the lone pairs in your molecular geometry, okay? And now let's go to number 6, when you have a steric number of 6 groups. So again, if you have 1 lone pair and 5 bonded groups, that's square pyramidal. And then here, if you have 2 lone pairs and 4 bonded, it would be square planar. I hope this helps a lot with like making sense of why sometimes it is and why sometimes it isn't. It might take a few times to watch this video. Again, these videos take time to create it, so please follow, like, share, and again, thank you for watching.